So exercise 5.8. This whole lesson is about Rolle's theorem, mean value theorem, Lagrange's mean value theorem. So normally children get confused which is mean value theorem, which is Rolle's theorem. You must remember by graph, okay? The mean value theorem, it's x-axis and this is y-axis. There's an x-axis and a y-axis. A Rolle's theorem will look like this. It will be a graph which is continuous from A to B, where this will be A and this will be B on the x-axis. And this will be continuous from A to B, but the graph will be like this. Can you see where f of A, this will be A and this will be B on the x-axis, and this will be f of A and this will be f of B. F of A and f of B will be different point, but here f of A and f of B will be at the same point. Can you see? So that's the basic difference between Rolle's theorem and mean value theorem. So in Rolle's theorem is a function which is continuous from a closed bracket A to B, where f of A is equal to f of B, where the function will not be differentiable at a point. The function will not be differentiable at a point. That is dy by dx or f dash of x will be equal to 0 at some point, and that point will be C, and that C will lie between A and B. So what is it? Rolle's theorem is about the gobra maji kizhendhu இப்படி வந்து gobra uchi ponum, where there will be point A and B on the x-axis. The y value pertaining to A, that is f of A and f of B will be equal. Then அப்படி gobra மாதிரி form ஆகி உச்சியில வந்து you cannot do a slope on the top. If you differentiate, it will become equal to 0. That is f dash of x, or dy by dx in other words is called f dash of x, which is becoming equal to 0. அப்படி equate பண்ணலாம். அப்போ you will get a point value for x. For example, 2x plus 1 or 2x square plus x is the function. 4x plus 1 is the differentiated value, which will become equal to 0, because உனக்கு தெரியும் ஏதோ உச்சியில் ஒரு பாயிண்டில் ஸ்லோப் பண்ண முடியாது, where x is equal to minus 1 by 4. So that x is called C. That C is a point which is minus 1 by 4 here, where you cannot differentiate. Okay, one more go. A Rolle's theorem for a function which is continuous from A to B. F of A should be equal to f of B. If f of A becomes equal to f of B, then f dash of x will become equal to 0. That is, they would give in the question f of x, you can differentiate that and equate it to 0. When you do that, you will get the x value, and that x value is from x-axis, right? You can call that x value as C, where C will lie between A and B. So define Rolle's theorem for a function which is continuous for a closed interval A to B, where f of A equals f of B. There exists a point C which lies between A and B, where f dash of C is equal to 0. X க்கு பதிலா C, f dash of x ன்னு சொல்றதுக்குள்ள f dash of C is equal to 0, because f dash of x and the x value is called C. Again, one more go. For a function which is continuous from closed bracket A to B, where f of A is equal to f of B, there exists a point C between A and B, where f dash of C is what is equal to 0. That is, the slope vanishes at one point and the point is known as C. Okay, so let me do a sum for you. F of x is equal to, first sum is x square plus 2x minus 8. You have to verify from minus 4 to 2. So this is only a rough graph that I am doing, okay. So you don't have to worry about where is minus 4. Minus 4 and 2, we are calling it as A and B. So f of A should be equal to f of B. Is it true? F of minus 4 and f of 2, are they the same? Substitute in the question and see. 16 minus 8 is 0. F of 2, put in a 4 plus 4 minus 8. 8 minus 8 is also 0. X square plus 2x minus 8. So when you substitute minus 4, 4 4s are 16, minus 4 here is minus 8, minus 16. So both f of minus 4 and f of 2 became same. So therefore you can verify Rolle's theorem, correct? Rolle's theorem can be verified because f of a is equal to f of b na gobra uchi mari இப்படி form ஆகும். Graph is also continuous because any quadratic function will be continuous function, right? Yeah. So there exists a point C between A and B where f dash of C is equal to 0. So let's differentiate this. 2x plus 2 is equal to 0. Because the condition satisfy anathnala differentiated value can be equal to 0. Hence x is equal to minus 1. Is minus 1 lying between minus 4 and 2? Yes. Minus 1 is lying between minus 4 and 2, and we can call this as C, and f of minus 1 is what is equated to 0, correct? So thus Rolle's theorem has been verified. Okay. Now then what is Lagrange's mean value theorem? It's like this, right, where this is A and this is B. This will be f of A and this will be f of B. And from the graph, you know, it's continuous from A to B. The function is continuous from A to B closed interval. F of A is not equal to f of B is when you can verify Lagrange's mean value theorem, which states that it is differentiable at every point. You can do a slope. Here the slope vanishes. Here the slope never vanishes. Never vanishes. Slope எல்லா இடத்துலயுமே இருக்கும். இங்க it vanishes at one point. உச்சில, கரெக்ட்டா? So the slope never vanishes, and slope is f dash of x, whose formula is f of b minus f of a by b minus a. How did it come? Just check the graph. Opposite by adjacent is what is slope. This is f of b, this is f of a. So f of b minus f of a by b minus a will be opposite by adjacent, which is f dash of x. Okay, so this is known as Lagrange's mean value theorem. Let's do a sum for this. So let's take the second sum, third subdivision. F of x is equal to x square minus 1, where x is lying between 1 and 2. Here f of 1 will be 1 minus 1 0, f of 2 will be 4 minus 1 3. Therefore you know this is a and b, you know f of a is not equal to f of b. So hence you cannot verify Rolle's theorem. You can only verify Lagrange's mean value theorem, LMVT. So let me verify that. This is 1 and this is 2, and f of 1 is equal to 0, and f of 2 is just rough graph, f of 2 is equal to 3. And what is f dash of x? F dash of x is f of b minus f of a by b minus a. What is f of b? F of 2 minus f of 1 by 2 minus 1. F of 2 itself is 3 and this is 0. So 3 minus 0 by 1, so slope is 3. So you can do a slope and the slope's value will be 3, correct? And where will that slope be? That point for which you take this question and differentiate it, you get 2x, which is also a slope. This is also a slope. You have done a slope using formula. This is, you have done a slope by differentiating the function. Equate both. X is equal to 3 by 2 or 1.5 is a point which lies between 1 and 2 where I am doing a slope and the slope's value happens to be 3. That's the meaning of Lagrange's mean value theorem. So you understood how to define Rolle's theorem, how to define mean value theorem. Mean value theorem is a continuous function from a to b where f of a is not equal to f of b, then it is differentiable, the slope does not vanish, and the slope f dash of x is given by f of b minus f of a by b minus a. I am doing this extra. This is an additional thing that I am doing. They have not asked me to do. They have not asked me to find the point at which slope is 3. No, they haven't asked, but I am doing it. Okay, now going to the second question. I have to verify Rolle's theorem for a greatest integer function lying between 5 and 9. How to draw a greatest integer function? Fill, don't fill from 0 to 1. From 0 to 0.99, the answer is 0. 1 to 1.99, the answer is 1. 2 to 2.9999, the answer, you have done this last year, right? So likewise, from 5 to 9, f of greatest integer function of 5 and f of greatest integer function of 9 have got two different values. 5 and 9 will be the answers. So f of a is not equal to f of b, hence you cannot verify Rolle's theorem, that's all. So you might ask me, auntie, can I verify mean value theorem? You cannot verify. Even though f of a is not equal to f of b, this graph is a discontinuous function between 5 and 9, it is not continuous, hence both cannot be verified for this. Even the second sum stays the same. Third subdivision, I have already done it for you last video, in the previous sum, okay. Third sum, if f of minus 5 to 5 is the domain, is related to range of real numbers, a function between minus and 5 is a differentiable function avane kuduthran. Appadina you can only verify Lagrange's mean value theorem, ena adla dhaan you can differentiable function irukku, correct ah? It's a differentiable function from minus 5 to 5, ella edathiliyume it's differentiable. You have to prove that f of a is not equal to f of b, or in other words question la f of minus 5 is not equal to f of 5. Idu vandu converse of Lagrange's mean value theorem. Ena what is the definition for Lagrange's mean value theorem? If f of a is not equal to f of b, then it's differentiable, and differentiable formulas f dash of x formula is f of b minus f of a by b minus a. This is a theorem. It's given that it is differentiable. So idhula start pannom. And write f dash of x is not equal to 0. Hence f of b minus f of a by b minus a is not equal to 0. Hence f of b will not be equal to f of a. Hence f of minus 5 is not equal to f of 5, since it's differentiable. Ipdi no converse of it, okay. Let's go to fourth sum. Fourth sum is f of x is equal to x square minus 4x minus 3 for interval a is equal to 1 and b is equal to 4. You have to verify mean value theorem. Mean value theorem, check what is f of a, what is f of b, which is 4. 1 minus 4 minus 3 is 1 minus 7, which is minus 6. F of 4 is 16 minus 4 16 minus 3 is the answer. So f of 1 is not equal to f of 4. So f of a is not equal to f of b. Hence you can only verify mean value theorem. My answer right, 1 minus 4 minus 3 is 1 minus 7, so minus 6. Substituting 4 in the place of x, 16 minus 3 minus 3. So f dash of x can be verified, which is f of b minus f of a by b minus a. F of b is minus 3 minus of minus 6 f of a by b minus a. What is b and a? B minus a for 3. Minus 3 plus 6 by 3 is 3 by 3. So answer is 1. Thus you get the slope as 1. But suppose they ask you at what point is the slope 1, then you have to differentiate 2x minus 4 and equate it to 1. 2x is equal to 5, x is equal to 5 by 2 or 2.5, which will come between 1 and 4. So it's fair enough, correct? But they haven't asked all that, you can stop with this. But if they ask, you should know, that's all. Next question is fifth question. Again verify mean value theorem for x cube minus 5x square minus 3x. You have to verify mean value theorem where a is equal to 1 and b is equal to 3. In mean value theorem, if it will be like this, is a is 1 and b is 3. F of a should not be equal to f of b, right? So check what is f of 1. It's 1 minus 5 minus 3, which is 1 minus 8, so minus 7. What is f of b? F of 3, which is 3 3s are 9, it is 27, sorry. Minus 3 3s are 9, 9 5s are 45, so minus 45. Minus 3 3s are 9. So 27 minus 54 is minus 27. So f of 1 is not equal to f of 3. F of a is not equal to f of b. Hence you can verify mean value theorem, which is f dash of x is equal to f of b minus f of a by b minus a, which is f of 3 minus f of 2 by 3 minus 1. What is f of 3 is minus 27. What is f of 2? F of 1 is minus of minus 7 by 3 minus 1, 2 is minus 27 plus 7 by 2, which is minus 20 by 2, so minus 10. So you got the slope. You can also differentiate the question and equate it, but they haven't asked, so you can leave it like that. Then they have another subdivision in that, find all C an element of 1 comma 3, between 1 and 3, you have to see if f dash of C is not equal to, is equal to 0. How is it possible? We just verified between 1 and 3, we can do a slope at every point, right? So it will never be equal to 0, because its f of A is not equal to f of B, f of 1 is not equal to f of 3. So f dash of C is never going to be equal to 0, slope will never vanish, that is all. Sixth sum. Explain the applicability of mean value theorem. Yeah, I have told you they are discontinuous functions, so exercise 2, sum number 2 also, the discontinuous, and hence you can never verify mean value theorem or Rolle's theorem, that is all done. Hope you are clear. See, anyone wants this after going through this video again and again, still you have a doubt, you can call me, I can teach you. I want you to do it. I do not want to do it again in Zoom now. I am sitting and doing the video for hours together, and I am not going to come on Zoom, because Zoom classes is not going to clarify your doubts because you will be on mute. So do these sums at home and come back to me for doubts.